Science!
Welcome to Science this week, guys. I just got to say at the top here, I love doing this segment every week because not only do we get to talk about some really fun topics in science and space exploration, but it's fun to kind of check back into stuff that we've talked about on previous episodes. I love learning new material and new data from some of these things that we've talked about, and it just makes this journey a lot of fun, and I'm glad you're along for the ride with me. First up this week, let's check in on Mars and NASA's InSight lander. As we know, it landed. And the InSight lander landed on Mars, and it's been up there gathering a bunch of new data that we've never been able to look for on Mars, including seismic data. One of the things that InSight is there for is to measure seismic data on Mars. And that's with its Seismic Experiment for Interior Structure, or SEIS, instrument. And it detected its first faint seismic signal on April 6th of this year. And that was actually the 128th day that the InSight lander was on Mars. And the days on Mars are called sol. So it was the 128th sol. Mars and the moon do not have tectonic plates like we have here on Earth. But they still experience quakes. We actually know that the moon does as well. And because in their cases, it's caused by a continual process of cooling and contraction that creates stress. And once this stress builds up over time, it gets strong enough to actually break the crust, causing a quake. So a Mars quake is still technically in the same vein as what happens here on Earth. It's just not created by the shifting of tectonic plates. Dr. Lori GLAZE, the Planetary Science Division Director at NASA headquarters, said the Sol 128 event is exciting because its size and longer duration fit the profile of moonquakes detected on the lunar surface during Apollo missions. However, this event, this Sol 128 event that was detected, was too small for the Mars InSight lander to have enough solid data to basically look into the Martian interior. And that's one of InSight's main objectives. That doesn't mean that it won't happen. It's exciting enough that this tiny event happened, but it didn't happen to the magnitude that we wanted it, and we were looking for in the beginning. Dr. Bruce BANERDT, not Dr. Bruce Banner, from NASA's Jet Propulsion Laboratory said InSight's first readings carry on the science that began with the Apollo missions. We've been collecting background noise up until now, but this first event officially kicks off a new field, Martian seismology. And that's really exciting because, again, this is something that we've theorized, that we've been able to slightly detect from other rovers that have been up there, but we haven't had the correct instrumentation to really detect an actual quake on Mars until now. And I have some very haunting audio directly from the InSight rover of what appears to be this tiny seismic event on Mars. And here's that. So creepy, right? Like, just the otherworldly sounds that we're getting. But what's really exciting about this is that this means that Mars isn't dormant, that what we believe, the buildup of this stress and the release of the stress, creating Marsquakes, does happen. We don't really know the frequency yet, or if this is the biggest one that we'll detect. But we are at, everyone at NASA and a part of this is crossing their fingers that this is not just a singular occurrence, and we're going to detect not only more of these, but bigger ones. Because if we can get a bigger one, it can actually help us map out the interior of this planet, which is incredibly exciting. It's something we know next to nothing about, what really is on the inside of Mars. And that'll be something that we'll be doing even more of when we land next year's rover, the Mars 2020 rover, and with more instruments, more data coming back. And eventually, when humanity makes it to Mars, one of the first things we're going to do is dig, and we're going to see what the heck is under the ground. So we're kind of getting a little bit of that picture before that, which is really exciting. Dr. Philippe Longuyon of the SCIS team said, "We've been waiting months for a signal like this. It's so exciting to finally have proof that Mars is still seismically active. We're looking forward to sharing the detailed results once we've had the chance to analyze them." And again, that's really exciting because we've been following the journey here on the science segment at Fuel by Death Show. We've been following this journey of this incredible instrument on another world, and the data it's already producing is really, really exciting, and it's only going to get more exciting. This was the first event that has been detected, and it's only been up there for a few months. Imagine the data we're going to have in a year, a couple years. It's going to be really, really exciting to see what the interior of the red planet actually is. It could be anything. There could be aliens under there. Nah, maybe not aliens, but it is exciting to dream about. Who knows? Who knows if it's solid, if it's cavernous, kind of like some of what Earth is. Like, we have no idea what's in store, but we're going to get those first readings very soon, and I can't wait. We'll talk about it right on this show, obviously. Another topic that we talked about recently on this very segment was Sophia. And Sophia has found the universe's first molecule. Now, let me unpack this a little bit. The first type of molecule ever formed in the universe has been detected in space for the first time after decades of searching. Scientists discovered its signature actually in our own galaxy, utilizing the world's largest airborne observatory, SOFIA, or the Stratospheric Observatory for Infrared Astronomy. That's the giant aircraft that flies around with the telescope in the lab inside of it and lands and upgrades itself. We did a whole segment on it. It's incredible. It's incredible. When the universe was still young, only a few kinds of atoms existed. And I just want to take a second and say I can't say enough good things about Neil deGrasse Tyson's new books, Astrophysicist for People in a Hurry. It's a real short read, and it's just an interesting look at the universe and the creation of everything, told from Neil, but in a way that you can understand it. And there's a whole chapter on like the Big Bang and what it created, the atoms that it created, and how they interacted with the photons. My understanding is way better after reading this book, and I can't recommend it enough. But anyway, scientists believe that about 100,000 years after the Big Bang, helium and hydrogen, which both existed at that time, combined to form a molecule called helium hydride. And this would have been the first molecule ever formed after the Big Bang. And it should be present in some parts of the modern universe, but we've never detected it in space until now. Sophia found modern helium hydride in a planetary nebula, a remnant of what was once a sun-like star located 3,000 light years away near the constellation of Cygnus. This planetary nebula, called NGC 7027, has conditions that allow this mystery molecule to form. The discovery serves as proof that helium hydride can, in fact, exist in space. This confirms a key part of our basic understanding of chemistry and of the early universe and how it evolved over billions of years into complex chemistry that we know today. Harold Yorke, the director of the Sophia Science Center in California's Silicon Valley, said this molecule was lurking out there, but we needed the right instruments making observations in the right position. And Sophia was able to do that perfectly. this is really exciting because, again, this is something that we've theorized exists out there in space, but we've never been able to detect till now. And I have a fun little video all about Sophia finding this molecule right here.
The universe today is filled with planets, stars, galaxies, but what came before? After the Big Bang, the early universe only had a few types of atoms, mostly helium and hydrogen. Scientists believe that helium and hydrogen began to combine to form the universe's first molecule, called helium hydride. These molecules led to the creation of new molecules that helped cool the early universe. Over billions of years, the universe transformed, becoming the complex place it is today. Scientists have never found helium hydride in space, until now in a planetary nebula. Flying high in the Earth's atmosphere with SOFIA, the world's largest airborne observatory, scientists finally detected this elusive molecule. SOFIA, a partnership of NASA and the German Aerospace Center, uses cutting-edge technology. Its instruments are easily upgraded, unlike other observatories in space. SOFIA's detection of the first molecule that ever formed confirms a key part of our basic understanding of the early universe.
So like that said, we know that the universe today is filled with large, complex structures, your planets, your stars, your galaxies. But 13 billion years ago, that was not the case. Following the Big Bang, it was the universe was just basically this hot mess. And there was just a few types of atoms, mostly helium and hydrogen. As atoms combined to form molecules, the universe was finally able to cool and began to take shape. And scientists have always inferred that this helium hydride molecule was this first kind of primordial stuff in the universe. Well, you know how we talk about like the primordial goo that life sprung from on Earth? Think about that same goo, but in the universe. Something had to kind of coalesce to make everything that we see now, which is crazy. So once cooling began, hydrogen atoms could interact with helium hydride, leading to the creation of molecular hydrogen, the molecule primarily responsible for the formation of the first stars. And stars are basically like the factory of everything. They went on to forge all the elements that make up our rich chemical cosmos today. The problem, though, is that scientists could not find helium hydride in space. We believed it must have happened. All signs pointed to like this must have happened, but we've never been able to figure it out that true data until now. This first step in the birth of chemistry was unproven. We knew where we are in chemistry, but we never were able to prove where chemistry started. And now we have, thanks to SOFIA. And that's what's so amazing about SOFIA, because not only does it fly around above a lot of the water vapor that ground-based telescopes have to, wade through all of that water vapor to get a good, clear picture of the universe. SOFIA is flying high in the atmosphere, but it's not tethered in space. The worst thing about what we have in space, like the Hubble telescope or the TESS telescope, these types of instruments, once we put them in space, they're pretty much there. We can create a space mission to go up and work on it like we did with the Hubble, but that takes a lot of manpower, a lot of funding, and it's just not something that's viable all the time. So basically, we create that piece of technology, we put it in space, and that piece of technology remains intact for the time frame that we created it. SOFIA is different, and that's what's so exciting about something like SOFIA. Every time it flies, it also lands. So all the time, scientists are working to upgrade the systems in SOFIA, upgrade the lenses, upgrade the telescope, upgrade the computer systems in there. So it constantly has the most cutting-edge technology working on this instrument. So it's one of the most important scientific instruments we have today, and it's built in a frickin' jet. It's so cool. If you missed our science segment on SOFIA, I encourage you to go back and listen and watch that. Or check out NASA.gov, and all of their amazing material they have on the SOFIA project. It's just eye-opening and incredible that we're doing something like that in the field of science. And that's why I love talking about science every week with you, because it is just so exciting.